Dear students, we are learning about atoms and molecules, and in this topic already we learn about atom and molecule and kinds of atom and types of molecules and what is atomic mass, molecular mass, gram atomic mass, gram molecular mass, and further we have to revise Avogadro hypothesis and the applications and the relation between volume of gas and the number of molecules. For this we are going to in this chapter, and the main postulates of modern atomic theory already were revised. That is, atom is no longer divisible. Atom is no longer indivisible. And the isotope, also isobar, artificial transmutation, and atoms may not always in a simple ratio. Atom is smallest particle that take part in chemical reaction. And what is atomic mass and the relative atomic mass? Atomic mass is always compared to the standard mass of carbon 12. So it is simply a number. There is no unit for relative atomic mass. But when you express it in terms of gram, it is called gram atomic mass. And some examples are given in the table 7.1, relative atomic mass of elements based on the carbon 12 scale. Also, how to find out the average atomic mass using the formula of average atomic mass, that is mass of first isotope into its abundance plus mass of second isotope into its abundance. And further, the atomic mass of the sum of the elements like hydrogen, helium, lithium, beryllium, boron. And next, molecule. It is a combination of two or more atoms, maybe in the same kind of atom or different kinds of atom. If you have same kind of atoms, it's going to be called as a homoatomic molecule. Different kinds of atom combined to form a molecule means heteroatomic molecule. And also, the number of atoms present in a molecule is termed as atomicity. And based on the atomicity, classification is made like monoatomic, diatomic, triatomic, polyatomic. Also, how to find out the average atomic mass, the isotopic elements like nitrogen, sulfur, chlorine using the given formula. And the activity 7.2 is given how to classify the molecules based on atomicity. When two atoms in a molecule, that is going to be diatomic. If it contains only same atoms, that is going to be homodiatomic. So fluorine is homodiatomic. Carbon dioxide, there are three atoms, carbon and two atoms of oxygen. So three atoms. So it is going to be triatomic, different kinds of atoms. So it is going to be a heterotriatomic. And there are polyatomic molecules also there, like methane, glucose, sulfuric acid, ammonia. So all this he learned how to classify the atomicity based on the number of atoms. And a relative molecular mass. So molecular mass also is simply a number, there is no unit. We are going to compare the molecular mass of any element using the standard carbon 12 scale. Then simple differences between atoms and molecule, because atom is a very smallest particle, molecule is smallest particle, but it can exist in free state. Atom cannot exist in free state. And there are some atoms which can be highly reactive compared to noble gases, but molecules are less reactive. Atom does not have chemical bond. but molecules always combined, having strong force between the atoms. Then the mole concept. Mole is nothing but going to denote the number of particles present in the given substance. The number of particles already we learned. And for example, say we use this type of terms in our normal life. That is the pair. Pair means going to denote two number or two items. Dozen means it's going to define 12 numbers or 12 items. Similarly, mole means number of particle or number of atoms or number of molecule in the given substance. So that is also defined based on the carbon 12 scale. And the value of Avogadro number is 6.023 into 10 power 23, and based on the significance given by the Amedeo Avogadro, the name is given Avogadro number. Then 1 mole of any gas always occupy the volume of 22.4 liter, which is equal to 22,400 ml at STP. This is called a molar volume. And 1 mole of any substance always have Avogadro number of molecules, or simply we used to say entities or particles. So 1 mole of oxygen, or 1 mole of carbon dioxide, or 1 mole of ammonia, or 1 mole of nitrogen, which is equal to 6.023 into 10 power 23 molecules. And next calculation based on the number of mole using the given details, like mass, atomic mass, mass by molecular mass, number of atoms by Avogadro number, number of molecules by Avogadro number. So in this picture 7.3 it is given clearly. So mole means that mole which is going to comprise these 1 mole of substance occupy 22.4 liter at STP. At the same time, 1 mole of any substance always have gram molecular mass of substance. 1 mole of any substance, for example ammonia, 1 mole of ammonia mean which is going to have that gram molecular mass. That is nitrogen is 14, hydrogen 3 hydrogen, so 14 plus 3 17 is the gram molecular mass, that is equal to 1 mole. Also 1 mole of any substance have Avogadro number of particles 6.023 in 10 power 23 particles. Simple explanation using the picture 7.3. Then how to calculate percent composition using the formula mass percent of an element is equal to mass of that element in the compound by molar mass of the compound into 100. So the mass of the element in the compound, for suppose if we take water, that is compound which consists of hydrogen and oxygen, and the mass of hydrogen in the given compound, and the total molar mass of water into 100. So in this way we can calculate the mass of any element in the mass percentage of any element in the given compound. And next see the Avogadro hypothesis. The Avogadro bring out the relationship between number of molecules to volumes of gases. So Avogadro hypothesis is based on the volume to gases. So equal volume of gases occupy equal number of particles. That is Avogadro law at the same temperature and condition. Then there are a few applications of Avogadro law. First one, see, it explain Gay-Lussac's law. It explain Gay-Lussac's law. And also it helps to determine the atomicity. So Gay-Lussac's law also going to explain about, going to derive about the gaseous substance. Whenever gases combine, they combine in simple ratio. The product also gas means the simple ratio extend to the product. That is Gay-Lussac's law that you have already learned in 9th standard. Atomicity learned in this lesson, that is a number of atoms in a given molecule. Then molecular formula of elementary gases can be derived using this Avogadro hypothesis. Then how to bring out the relation between molecular mass and vapor density can be done using this Avogadro law. And gram molar volume, that is gram molar volume means 1 mole of any gas weighs occupy 22.4 liter at STP. That is equal to gram molar mass. So these are the few applications. Then next one, relation between vapor density and relative molecular mass. This is also important topic and will be asked in the 5-mark detail. How will you relate or bring out the relationship between vapor density and molecular mass? And first you have to define what is relative molecular mass, then what is vapor density. Then you have to combine these two and bring out the relationship. Based on the hydrogen scale, the relative molecular mass already we learn, that is the ratio between mass of one molecule of gas to mass of one atom of hydrogen. The ratio between mass of one molecule of gas to mass of one atom of hydrogen. That is the relative molecular mass. And the vapor density, it is the ratio between certain volume of gas to the same volume of hydrogen. It is the ratio between certain volume of gas to the same volume of hydrogen. So vapor density can be written using the derivation form, that is vapor density Vd is equal to mass of a given volume of gas or vapor, all this taken at the same temperature and pressure, by mass of same volume of hydrogen. So we are taking same volume. So same volume of gases always occupy same number of molecules. This is based on the Avogadro hypothesis. Avogadro hypothesis says equal volume occupy equal number of molecules. That is V proportional N. V is directly proportional N. That already learned. V means volume of gas. N means number of molecules. Proportional means directly proportional. When volume increase, number of molecules also increase. And volume decrease, number of molecules also decrease. So vapor density at standard temperature and pressure at the next step. Given volume, suppose if you take a particular one volume, that is 1 liter or 2 liter, whatever it may be, it's going to have the equal number of molecules. So at the given volume, n molecules are present. We are going to consider at the given volume, n molecules of gas is there. Similar number of molecules will be there in the hydrogen, because we are taking same volumes of gases. Then next, see, if suppose n is equal to 1, suppose the n volume contain one molecule, we can derive the next step. Vapor density is equal to mass of one molecule of gas to mass of one molecule of hydrogen. So in the hydrogen molecule, there are two hydrogen atoms. That's why it is hydrogen is diatomic. H2 contain two atoms in one molecule. So we can write mass of one molecule of gas to mass of two atoms, because one molecule contains two atoms. And next, see, vapor density is equal to mass of one molecule of gas to, we can bring out the 2 here, the bigger, and we can write 2 into mass of one atom of hydrogen. Then relative molecular mass based on hydrogen scale is mass of one molecule of gas to mass of one atom. And therefore we can substitute the equation in the vapor density. We can bring out vapor density is equal to, so mass of one molecule of gas to mass of one atom of hydrogen is nothing but that is going to be relative molecular mass. So we can write vapor density is equal to relative molecular mass by 2, and when you do cross multiplication we can get 2 into vapor density is equal to relative molecular mass. This also can be written in another form, relative molecular mass equal to 2 into vapor density. So if you know the vapor density, you can bring out the relative molecular mass by multiplying into 2. So this is the simple relation between vapor density and molecular mass, that is relative molecular mass is equal to 2 into vapor density. This is the relation between vapor density and molecular mass, and this is a simple one, will be asked in the exam. Next, see next how to solve the problems using the given details. Calculate the gram molar mass of the following: water formula H2O, carbon dioxide, calcium phosphate, and we should know the atomic mass of these elements. It is already given in the previous table. From the table you have to know hydrogen atomic mass is 1, oxygen 16, nitrogen 14, sulfur 32, and all this you have to keep in mind. So we have to first find out the molar mass. Molar mass: hydrogen atomic mass 1, oxygen 16. There are 2 hydrogen in the water molecule, only 1 atom in the oxygen molecule. So you have to multiply the atomic mass by the number of atoms. So 2 atoms into its atomic mass. Similarly, 1 atom of oxygen into its atomic mass. So 1 atom of that is atomic mass is 1 for hydrogen. Its number of atom is 2, so 1 into 2. The atomic mass of oxygen is 16. Number of atom is 1 into 1. So 1 into 2 plus 16 into 1. So 2 plus 16, that is 18 gram. Simple multiplication using the atomic mass. Similarly, carbon dioxide atomic mass is 12, and oxygen similarly 16. So only 1 carbon atom. There are 2 oxygen atom. So you have to multiply the number of atom into its atomic mass. It will give 44 gram. Then calcium phosphate. Calcium atomic mass is 40, phosphorus 30, oxygen 16. And you have to multiply the atomic mass by its number of atoms. So 40 is the atomic mass of calcium into its number of atom 3. 40 into 3, 120. Then phosphorus, P, that is atomic mass is 30 and number of atom is 2. Number of atom is 2. P4 twice is given. So actually 2. The oxygen 4, O4, also it is also divided by, it is also multiplied by 2. So you have to totally multiply the radical phosphate into its atomic mass using number 2. So 94 into 2, that is 188 gram molar mass of calcium phosphate, 308 gram. 308 gram. And next, see calculation based on the number of moles from the mass and volume. So first one, calculate the number of moles in 46 gram of sodium. Sodium, which is in the form of simply an element, the atomic form. So number of moles equal to mass by atomic mass. When it is given sodium, calcium or potassium, copper, aluminum, like that, all these are in the form of element form, that is atomic form. So mass by atomic mass formula can be used. So 46 is the mass of the sodium given in the calculation, divided by its atomic mass 23. So 46 by 23, when you are going to cancel, you will get 2 moles of sodium. So there are so many sums based on this mass by atomic mass, then the formula of mass by atomic mass. The next one, 5.6 liters of oxygen at STP. So each sum and different formulas are given, and you have to learn the formula. So when the volume is given, what to do? The formula is given volume of the substance, given volume of oxygen by molar volume of the given substance. So here oxygen is given, the volume of oxygen given is 5.6 liter, and its molar volume is 22.4 liter at STP. At STP, all the gases occupy 22.4 liter. So 5.6 divided by 22.4, that is equal to 0.25 mole of oxygen present in the given volume of oxygen. And now to calculate the number of moles of a sample that contains 12.046 10 power 23 atoms. So this is another type of sum. That is when the number of atoms given, what kind of formula can be used? That number of moles equal to number of atoms by Avogadro number. Number of atoms by Avogadro number. So how many atoms are given? 12.046 10 power 23 atoms are given. You have to take as numerator, and the denominator you have to write the Avogadro number, that is a standard determined value 6.023 in 10 power 23. So 12.04 10 power 23 divided by 6.023 10 power 23, when you are going to simplify, you can get 2 moles of iron. So 3 formulas are used in this calculation based on number of moles, mass and volume. First one is the first formula, that is number of moles equal to this number of moles equal to mass of the element by atomic mass of the element. So mass will be given, atomic mass you have tried from your mind, already you learned, or it is given in the table, sometime will be given in the question paper. So you have to know the formula. Whenever you do the sum, you have to write the formula and then substitute the given values, and next simplify and bring out the answer and write using the unit. And when volume is given, this formula can be used, that number of moles is equal to given volume by molar volume. Given volume by molar volume. Then when you are given number of atoms is given, you can use number of moles equal to number of atoms by Avogadro number. So 3 different types of formulas are used to find out the number of moles. When mass is given, mass by atomic mass formula can be used. When volume is given volume by molar volume formula can be used. When number of atom is given, number of atom of the substance by Avogadro number. This formula can be used to find out the number of moles. Then next, how to calculate mass from the mole. Already we calculate mole from the mass. Mole, when mass is given, how to calculate mole we learn, that is the formula is mass by atomic mass. Now in the next topic, how to calculate mass from the given mole. For example, 0.3 mole of aluminum. Atomic mass is given here. 0.3 mole is given. We have to find out the mass of the substance. The same formula can be modified to find out the mass. Here this is the formula to calculate the number of moles. This formula already learned, that is number of moles is equal to mass by atomic mass. This formula is going to be modified to find out the mass. Here number of mole is given. I have to find out the mass of the substance. So mass is equal to number of moles into atomic mass. Mass is equal to number of moles into atomic mass. In the given formula, slight modification you have to do to bring out the mass. So mass is equal to number of mole is 0.3 mole. 0.3 mole is given in the calculation, the problem, and its atomic mass also given. Sometimes it will be given, that is atomic mass of aluminum, because we are taking aluminum for the calculation. Atomic mass of aluminum is 27. So you have to simply multiply the number of moles into 0.3 into 27, that is 8.1 gram. 8.1 gram. Whenever mass is given, you have to write in the unit of gram. Then next sum, 2.24 liter of sulfur dioxide. 2.24 liter of sulfur dioxide. How to calculate the mass? So we know the formula to calculate number of moles. So we have to calculate the number of moles using this formula. Number of mole of sulfur dioxide or any gas given volume by molar volume. What is the volume given? The given volume is 2.24 liter. 2.24 liter is given here in the sum. 2.24 liter. Molar volume at STP is 22.4 liter. That is the determined value, constant value. So you have to write the given value as numerator, 2.24 divided by 22.4. And when you go into, you can multiply by 100, or you can simply also you can cancel to bring out answer 0.1 mole. First you have to find out the number of mole. Then from the number of mole, we have to use another formula for this sum, that is number of mole is equal to mass by molecular mass. Because sulfur dioxide is a molecule. When atom is given for atomic form, that is sodium, aluminum is given, you can write mass by atomic mass. Here sulfur dioxide is a molecule, so you have to write mass by molecular mass. So from this you can get mass is equal to number of moles into molecular, because we already know the number of mole. So number of mole is going to be substituted. So mass is equal to 0.1 mole into its molecular mass. Molecular mass of sulfur dioxide is 64. Sulfur 32, oxygen, one oxygen atom, atomic mass is 16. Two atoms are there in the sulfur dioxide. So 2 into 16, 32. So 32 plus 32, 64. So 0.1 into 64, it is 6.4 gram. Then how to calculate the mass of 1.1 in 10 power 23 molecules of water. Now it is given molecule is given. So you have to find out the formula whenever molecule is given or atom is given. In the previous column it is given, there is a number of atoms. Now number of molecule is given. Whether it may be molecule or atom, we are taking as the molecule or atom in the numerator. Denominator is going to be the Avogadro number. So number of moles first you have to calculate using the formula. Using this formula, that is this is the formula for, that is number of moles equal to number of molecule by Avogadro number. So number of molecule of water is 1.51 10 power 23 and the Avogadro number is 6.023 10 power 23, and you can cancel this 10 power 23 10 power 23 and 1.1 by 6 can be cancelled. That going to be 1 by 4, 0.25 mole. Now number of mole is calculated. From the number of mole you have to calculate mass of the given substance using the same formula. The formula for number of mole is equal to mass by molecular mass. Because water is a molecule, so we are taking mass by molecular. What is the mass of water that we are going to calculate? So mass is equal to number of moles into molecular mass. So number of mole is 0.25 mole. Molecular mass of water is 18. 0.25 into 18, 4.5 gram. 4.5 gram. Whenever you write that number of moles, you have to write using the unit of mole. Whenever you write mass, you have to write in the unit of gram. Next, 5 and 10 power 23 molecules of glucose. Here also given the molecules of glucose. So what is the formula for glucose? That is C6H12O6. That is the formula for glucose. And you have to find out the molecular mass: carbon 12, hydrogen 1, oxygen 16, and atomic mass into its number of atom can give its molecular mass. So using the formula, mass by mass of glucose equal to molecular mass by Avogadro number. That is, molecular mass is 180 and the number of particles 5 in 10 power 23, Avogadro number 6.023, and when you are going to simplify that 10 power 23 can be cancelled, then 180 into 5 by 6.023 can give 149.43 gram of glucose is present in and the given 5 in 10 power 23 molecules of glucose. So you have to go through these sums using the formula. So you write the formula and try to substitute and calculate and bring out the answer and write the answer with the correct unit. And you have to go through whatever we covered in this topic, that you have to revise then and there. That is from the beginning. All this you have to go through in this topic. So that postulates of modern atomic theory, very very important topic in this. Then and you should know the tabular column 7.1 for the calculation. You should know this. From this relative atomic mass only we are taking the atomic mass of the substance to calculate number of moles or mass, and you should know the difference between atoms and molecules, and what is mole. Then you should know to write about the applications of Avogadro law, also the relation between vapor density and a molecular mass. Also there are some based on the uh, molar mass, how to calculate molar mass, mole and volume, also mass. Using the formula you can easily simplify. So you have to go through all this formula and make a note of all this in your separate notebook for the further revision. So practice and prepare well then and there. Don't waste time. Thank you.